Hello everyone, this is Damián Furman presenting the work we did with Hernán Melgrati at the Instituto de Ciencias de la Computación at the Universidad de Buenos Aires in Argentina. The work is about adding error messages for Gong, which is a tool for static verification of certain properties in Go programs. Go is a programming language relatively new that features message passing communication. It incorporates channels as basic types, and it also incorporates operations over channels as basic instructions. Fencing of Go is a work published by Lange at 2017 that proposed a technique for the static verification of communication properties in Go programs. There is an implementation for this technique by two different tools called Dingo Hunter and Gong. Dingo Hunter creates an intermediate representation of the Go programs that is later taken as input by Gong, which does the static verification of the properties. The thing is that Gong only returns a Boolean value indicating if the properties that we're trying to check are satisfied or not, but it doesn't say anything about how these properties may have not been satisfied or which instructions might be broken them. So what we did is to propose an extension in the implementation to improve tools usability and give feedback to the user about the program taken as an input. The two properties that Gong checks for are liveness, which stands that for any synchronization action launched at any thread is going to be executed eventually. So if this property is satisfied, it guarantees the absence of total or partial deadlocks. And the other property is safety, which stands that the semantic of communication over channels is respected, and this means that there is no channel that is closed twice, or there is no message that is sent over a closed channel. This is a brief example about how our tool worked before the changes we did and after the changes we did. We use this simple Go program that creates a channel on line 5 and then creates a parallel execution on line 6 that sends a value through that channel on line 12. The main thread then tries to receive a message 2 times in line 7 and 8. So on the second time that it receives this message, since the channel is synchronous, there is no synchronization action for this second receive operation, and there is a deadlock on line 8. Before our changes, the tool only recognized that this program doesn't satisfy the liveness property, but after the changes we did, not only that liveness is not satisfied is recognized, but there is also information about which line breaks that property, which is a receive operation on line 8, and there is also a brief history of execution or a trace of execution that says that before the operation executed on line 8, there was a receive operation that was successful on line 7, and that it synchronized with a send operation on line 12 that was launched by a spawn operation on line 6, which is the line where this parallel execution is launched. The way Gong works is the following. It first assigns a behavioral type to a program, and that type can be symbolically executed. During the symbolically execution, Gong builds a finished state machine that represents all the execution states that the program can traverse. After building the finished state machine, it checks for safety and liveness properties on each of the states of the finished state machine. All works include source code information on the type, basically references to lines of code, and then it modifies the execution of the states to create traces that keep track of the execution history. Finally, it reports the execution trace associated with the state that violates a certain property. And it's very important to say that our extension does not interfere with the original verification. Here we have one of the algorithms that was published with fencing of Go, which is called forSelect. forSelect creates 3 channels called down, A, and B, and then it launched 2 parallel routines called cell 1 and cell 2 that takes as input the 3 channels created. Each parallel routine tries to send from one channel and receive from the other at the same time using a select statement. While cell 1 tries to receive from the first channel taking as input and tries to send from the second channel taking as input, cell 2 does the inverse thing. It tries to receive from the second channel taking as input and it tries to send from the first channel taking as input. So there are always two possible synchronizations at the same time. And if the synchronization action is done over the second channels, both routines re-enter the loop and get to the same place as before. But if communication is done over the first channel, then both routines send a message over the down channel indicating that they have finished their execution and then return. What we did is we added a second message sent over the down channel on line 28, as we can see, line 28. And because the main function only received twice over down channel, then there are 3 messages sent over this channel, and this third message never has a synchronization action, and therefore there is a deadlock, a partial deadlock, on line 28 on routine cell 2. We now check the result of executing Gong before our changes. As we can see, there is recognition that this program does not satisfy liveness property, but we don't have any more information about what is happening on this program. If we check the result of executing Gong after the changes we did, we can see an error message displaying that there is a send operation without synchronization on line 28. A trace of previous execution leading to the error encountered is also provided. This trace can be read on 2 different levels. If we only check the unindented lines, these ones, then you can see the execution trace for the routine that caused the violation of the liveness property. For example, we can see that before the send operation on line 28, we had a send operation that was successful on line 27. As we can see, line 27 is the previous message sent through the down channel. And then we can see that there is a successful send operation on line 25, which is the message received on cell 2 before entering the case in which we are going to send a message through the down channel. And before that, we have a spawn operation on line 39, which is the line where the cell 2 routine is launched. But if we want more information on any of these synchronization actions, we can see the indented lines, and for example, we can see that the send operation on line 27 synchronized with a receive operation on line 42. Line 42 is the second receiving of the message on the down channel. Or for example, if we want to see which operation synchronized with the send operation on line 25, we can see that there is a receive operation on line 10, which is the sending operation that the receive operation that send 1 does on the channel 1, the first channel taking as input. Okay, so far we have just showed the enhancement we added to Gong. So to conclude, I'm going to talk about possibilities of future work. We identified 3 items on which there could be work to do. First one is evaluating alternatives to mitigate the overhead that is introduced by keeping histories on execution time. The second one is that Gong is restricted to programs that are fenced. This means that programs that have a finite amount of patterns of communication, even if the programs are infinite on their execution. So we can add feedback just for saying that these kind of programs are not fenced and why. And the last one is extending Gong to detect resource leakage, such as channels that are not closed, and an unbounded creation of non-terminating Go routines. So that's all, and we hope you have enjoyed this presentation, and here we are our emails in case you want to contact or ask us any questions.